Welcome back to our live training session here with our Honda EP3 Civic. This training module, we're going to turn our attention into doing our full throttle tuning on our mainline chassis dyno. We're going to look at how to dial in fuel, spark, and variable cam control. Now with the variable cam control, we're going to look for the broadest torque band possible out of our engine. So we're going to learn how we can utilize the torque reading on the mainline and doing the overlay function to be able to build that cam composite blend table out specific for our engine we're working with. Now in the spark timing, we're going to make sure that we're hitting or getting close to maximum brake torque. Again, we might be limited with knock on this particular engine because we are relatively high compression on pump gas. We don't have knock control, unfortunately, with the Fuel Tech. So other standalone systems, if you've watched any of their live training modules, such as AIM Infinity, Haltech, Motec, M-Tron, Link, they all have knock control built into the ECU boards, and we're able to utilize knock control in the calibrating and tuning process. With the Fuel Tech, we're not going to be able to do that. So I'm going to rely on somewhat of my experience doing a lot of K-series tuning to be able to sort out what is going to be an appropriate amount of spark timing or not. Now I'm just going to call this out. I'd expect anywhere between roughly 23 to maybe about 26 degrees of timing for a K-series engine on pump gas that's naturally aspirated. We're going to probably be in that range, and we'll see how the engine responds as we're adding our spark timing in. Now, there are ways to dial in and take a look at your variable cam control tuning without a chassis dyno. It's definitely a lot more challenging. I'll talk about some of those methods and techniques here in this training module. Now with spark timing, it's definitely best to do it on a chassis dyno because you want to see the cause and effect as you're changing the timing. If you're gaining 2 horsepower, you're not going to feel that on the butt dyno. If you're gaining something like 10, 20 horsepower, you're definitely going to feel that, but you're not going to have that before and after measurable change that you can actually see. So renting some time for a chassis dyno is always advisable anytime you're doing spark timing tuning, even variable cam control tuning if you know what to look for. And again, we're going to take a look at that process here in this training module. Now, the main fuel table needs to be dialed in. And specifically, if we jump here into the table, that's going to be between 60 to 100% throttle. So we haven't touched or hit this range of throttle operation or load on the engine. This training module, we're going to focus on dialing this in here from probably about 2,000 RPM up to approximately 6,500, 7,000 RPM. Now, we're going to be focusing on dialing in our engine without VTEC. So we have VTEC disabled right now. We turned it off. That's a specific choice because I want to make sure that I get the low cam sorted out, and then I can introduce VTEC. We'll take a look at that in the next training module, and then figure out what the engine wants in terms of the variable cam timing, spark timing, and fueling delivery with VTEC on. With Fuel Tech, we only have one fuel map, so we have to make VTEC and variable cam control work in a single map. It's definitely a disadvantage if you're used to working with a system like a Link G4X or an M-Tron or some of the Motec M1 programming. You have a lot of flexibility in terms of what you have in terms of a fuel table, spark timing table, variable cam control tables. We can actually have fuel, spark, and variable cam tables specific for low cam and then switch over to separate tables for high cam, which is the best ideal situation for calibrating and tuning a K-series engine. But with Fuel Tech, again, we have to make this all work within one table. So we're going to do the best that we can with what we have in terms of our tool set and our calibration within the software here. So we're going to learn how to dial this in. Now, taking a look, we're going to be working with our O2 correction under our full throttle. We talked about how to do that, and we've looked at that extensively in that last training module. Same process, same thing we're going to do here for full throttle. We want to make sure that our target is going to make sense because when we dial our entire fuel table in to hit this desired target, we don't have to come back in and retune the table if we want to change our desired target air fuel. So 70% throttle and higher, I am going to be targeting 12.5, 12.6 air fuel. That is ideal for a naturally aspirated K-series engine. Now you could try to target a little bit leaner mixture, but K-series seem to respond between 12.6 and 12.8. So I'm going to stick with a little bit more conservative value here, and we're going to run 12.6 air fuel for the target. So when we dial our main fuel table in, it'll be trying to hit this desired target. That's our ultimate goal. Just as we were dialing in our part throttle here, going through and doing our drivability from 40% throttle and lower in our table, we had our targets already set, and those made sense. So we want to have target air fuels under full throttle that make sense, that are all ready to go, and we have that. We know closed loop works, we know everything's going to be functional there, so we can rely on it for doing our calibrating and tuning in the training module. Now, let's talk about a few different things here where we have things set, and then we're going to talk about the process here. We'll look at the main line, get that set up for full throttle tuning, and then we'll do our first baseline pull. So jumping in here, let's go into our spark timing table. Now in our spark timing table, we stuck below 20% throttle to do the calibration process. So we found values here of roughly 20 degrees, 24 degrees, and then here roughly anywhere from 38 to about 42 degrees of timing in the part throttle. So this is pretty typical for a K-Series engine in terms of the timing that's going to want at lower throttle angles, at light throttle. Once we get under a load, once we have higher throttle angles, we're going to need less spark timing. Now, taking a look at the way I've set this table, 80 to 100% throttle, that's where we're going to be doing our full throttle pulls here. I have set the spark timing here to 14 degrees. Now, I'm expecting that I'd probably have my spark timing anywhere from roughly 23 to about 26 degrees of timing on low cam. On pump gas, we're way below that. I specifically have the timing here set really low so that we're able to focus on doing our fueling tuning first, also working with the variable cam control. And then the last thing, the last calibration process is going to be coming back into the spark timing table and bumping their values up and seeing the cause and effect here on the main line to tell if we're reaching or getting close to maximum brake torque. Now, we don't have knock control available with the fuel tech, unfortunately, so we're going to have to go in and just rely on what the dyno is showing us, how the engine's responding. I'm also going to rely on some of the experience I have doing the K-Series tuning about what the engine's going to want. So ideally, we would have some type of a knock monitoring device like a Plex or a tuner nerd hooked up to the engine. So if it was knocking, we'd see some kind of actual proof, or even wearing knock ears, knock headphones to be able to hear knock as I'm calibrating and tuning. I'm not going to include that in the training module because I can't broadcast the audio for you to hear the knock if it's happening. So I'm going to rely on, again, doing just the same thing as I was on the factory ECU with K-Pro, doing the calibrating and tuning, and let's say the knock control was completely unusable. What happens a lot of times on a built engine, I have to go in and just kind of feel out the engine and go slow with the spark timing and walk it up in reasonable increments and see how the engine responds on the dyno. Obviously, plug reading is probably the last step. I may or may not go in and pull the plugs out here as I'm doing the tuning, but we'll have to see how things go and how the engine responds. So the spark timing is conservative. That's going to be something we definitely want to make sure we have in place before we do any full throttle tuning and try to deal with our fuel. So it's always fuel first, then spark timing. Let's go down here to the variable cam control. So the other piece of the puzzle here is going to be our variable cam control. So we have our target set here to 30 degrees essentially in the cruise area, and we calibrated everything so that it was hitting that 30-degree range from 2500 to 6000. This is about the ideal variable cam target in part throttle area of operation for a K-Series, depending on if you're factory cam, stock cams like I have in here, or aftermarket cams. The variable cam timing will be pretty similar in part throttle. Full throttle will be completely different for every engine. Now, one thing I want to do here is actually go back into the table and zero out. Let's say the first little bit of the table here, we'll zero this out, and then we'll interpolate here. We'll do H through the rest of the table, and let's go ahead and save that. We want to call this, we'll call this low cam watt tuning. Let's go ahead and save that, and then we'll just write this change to the ECU here real quick. We're going to put that into the map slot 1. That's what we're working with here, doing this alpha N style tuning. So this has been set up to, we were only really sweeping to about 40% throttle. In this training module, we need to go figure out what our variable cam target's going to be here in our last 3 columns. This will be very specific to the engine we're working with, and depending how well it breathes and the breathing mods that we have. Obviously, we have individual throttle bodies. The thing that's going to be a downside for me is that I have a kind of okay header and a 2 3/8 inch exhaust. That's going to probably choke it up, so I may not be able to run as much variable cam timing in the table here, so as much advance and dialing in more overlap, because I'm probably going to get a blowback effect from that overlap, that aggressive overlap. If I'm trying to go in and command on the top end something like 30 degrees, the engine's probably not going to respond to that. It's probably going to lose power, if I had to guess, simply because the exhaust pressure exponentially increases as engine speed increases, and as a result, we'll find the engine's going to lose power. We're going to get the exhaust pressure, because it's exponentially increasing, it's going to be higher than the intake pressure. And if we have our valves open with the overlap, commanding more overlap here with the advance value, so commanding higher advance, we'll find that exhaust pressure is going to blow back into the combustion chamber. And as a result, we dilute the fresh air charge, and the engine actually becomes more knock sensitive and knock prone. So all things we want to avoid. We're going to figure out what works for this engine. Every engine's going to be a little bit different. We'll talk about the technique to do that here, but first I want to go in from 60 to 100% throttle and just zero this out. I want to baseline the engine with no variable cam target, so we can get a feel for things. And then what we'll do is we'll dial in the fuel table.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.